there are so many different ways that you can optimize your streaming and optimize your live streams to achieve a set of different objectives. Whether your objective be to have this rock solid end user experience that has all sorts of safeguards in it for different viewing environments, whether it's different players, whether it is different, particularly different network capacities or network availability that people have. There are a lot of things that are built into a live streaming workflow to really help safeguard that and accommodate it. On the flip side, there are other optimizations, especially what we're going to talk about today, that are focused in a different direction, and that is to achieve as rapid a possible as delivery to a stream into your audience's hands. Right, who really cares about that ultra low latency stream? So the people who are most interested in this are the people who benefit most from the real-time delivery, as opposed to having all those safeguards in place that I just mentioned for things like networks. These are going to be people who may be doing large corporate events over a large number of distributed remote offices. Just envision some large company like a Boeing or an IBM who's doing a very large corporate event, and you're going to have a moderator or a central moderator or one or more who's going to be fielding questions from remote offices in real time. It's really important that those questions are kind of triaged and handled in real time from the overall presentation. As those things get out of sync, that corporate presentation becomes less impactful. The same thing goes very much for medical or educational type of broadcasts, where questions are coming in that are very specific to a very specific set or step, in that procedure, need to really be addressed in real time. The same is with auctions, with gambling, live gambling events, with live gaming events. Having more or less a real-time connection between the action and the audience is critical to a lot of these workflows, where if you don't have it in place, it's cumbersome at best and sometimes not usable at worst. You can imagine having something like a live auction where there's 15 or 30 seconds delay on the live stream. That becomes a very painful and slow process when you are trying to field a bunch of bids coming in from different directions. So I like to just really go into the basics of the live stream processing chain. Again, this is really to kind of help our noobs in the audience understand all the components that go into getting video from the camera to the users. So once we capture from a camera, this could be a broadcast camera, this could be an IP camera, like a traffic cam or a security cam, a computer, and it can be from a mobile capture device like your cell phone. That ultimately takes those recorded pixels or that video stream and sends it to an encoder. An encoder's job is to compress the data for more efficient delivery. When it goes to the encoder, that's where you're going to start hearing acronyms like H.264, MPEG, API, MOV. That is where those acronyms fit in this workflow for people who are new to this world. That's also where you're going to hear the term codec. The codec's job is to compress and decompress this video signal. As a side note, it's very important that your source encoder and your playback encoder, support the same standard format protocol, whichever term you like to use best. We have seen in the past, it's increasingly less common. You will, have seen in the past probably at one point in your life, this codec is not supported. That is what that is. It is just that compression standard for basically more efficient delivery of the video pixels. So once the video is encoded, there is a step called transcoding that comes into play. The job of transcoding is to take your source signal and package it, if you will, into a bunch of different quality levels. The point of this is that you're going to have a distributed audience who's going to have different network accessibility. So the transcoder employs a technology or gives you a source of outputs that relate to something called the adaptive bit rate. And those are basically just different quality streams from the super highest quality that you can have based on the source that uses the most bandwidth to get across to a much lower quality version that uses a lot less info and takes less bandwidth to get across. This gives you the ability to connect with the most users in distributed environments overall. At that point, it essentially goes out to an origin server and goes through the process of this packaging. So the packaging services job, excuse me, is to start putting the encoded and optionally adapted bit rate video signal into something that I shorthand as like a deliverable envelope. This is where you're going to hear terms like HLS, MPEG-dash, RTMP, WebRTC, RTSP. It's really just a way of putting things in an envelope for delivery. You can think of it as a silly analogy of like, are you going to use the USPS, or are you going to use UPS, or you can use FedEx or DHL? It's really just a way of delivering things. Again, really oversimplifying this, but I want to paint, a very basic picture for our newcomers. Okay, so once that is packaged, ready for delivery, all things set up on your origin server, it's essentially ready for delivery. And the origin server works within a CDN, a term you've probably heard, Content Delivery Network, and that essentially negotiates between all of the remote viewers and the origin source to deliver the requested video streams. The CDN's job is really to quickly and affordably get your content to a distributed collection of end consumers, and to do it very reliably and very efficiently. The CDN involves both that origin as well as all of these edge locations. So you've probably heard edge servers, you've probably heard edge caching. These are strategically identified locations in a global network that are really optimized to deliver to that consumer base. Really, once you're at that point, you're really kind of at that final mile, something that you may have heard, where the player is ultimately receiving the data stream from the CDN, and it can begin that playback process. Okay, moving on. As we talk about latency and the interactivity continuum, there is a pretty broad spectrum of latencies that you will see across a variety of streaming services. So common latencies right now tend to be anywhere between 15 and 45 seconds. One of the things that's built into some of these common streams is frame buffering, so that the end user can kind of experience no disruptions even when we have network blips. This additional latency, if you will, relative to what we want to talk about today, also allows for this transcoding process, or these multiple bitrate streams, to be supplied to the end users. Again, to help accommodate for different network availability across your user base. So that's really a common span that you'll see there, anywhere from that 45 to 15. As we go down the spectrum, you'll see that you start to see OTT providers and things like live streaming and sporting events. For example, I'm a big tennis player, and I love to watch live streaming of U.S. Tennis Associations, U.S. Open, or any number of their various other events. They have a great app and a great website for viewing all these things. They do more work to reduce the latency, removing some of those optimization trade-offs for their user base, to get down to anywhere between 5 and 15 seconds. That's, we hear this common scenario all the time where you're watching a sporting event and you hear cheering from the neighbors next door because they got an update on social media before you saw it on the screen. So they're really trying to eliminate that gap. And then we really go down the spectrum into low and ultra low latency. This is where you're going to start hearing terms like RTMP and MPEG-TS and Wowza protocol and RTSP and WebRTC. Again, I really don't want to go into the details of how these protocols, these standards work. It's beyond the scope of this, but I think it's useful for the audience to know that that is where you will start to hear some of these technologies. We are going to be talking mostly today about the Wowza protocol, and in some of our future webinars, we're going to be talking about the implementation that we have of some of the others. Okay, so now that we've talked about latencies and we've talked about the components in a streaming workflow, we want to cover real quick about where the contributions really come to latency in the workflow, really tying the previous two slides together. Okay, so we can see in this, so what this diagram is designed to demonstrate here is that the bigger the bubble, the more latency that you're probably going to have in that process step. The capture phase and capture and encode phase is highly variable. So encoding latencies tend to be, let me say it this way, the latency introduced in the encoding step tends to be primarily based on how much buffering you want to introduce into your workflow. You would introduce buffering, again, to optimize for network differences, for very disparate user groups, to have a more seamless viewing experience. There are things that we certainly do here at Wowza to minimize that, and that is really just about minimizing the size of the number of frames or the group of pictures that go into an encoded packet. In the packaging step, which includes, kind of that stuffing into an envelope as well as the transcoding, we here Wowza have backed out, if you will, or we have eliminated that transcoding step to maximize efficiency. You will have a single bit rate, and the transcoding is not applied in an ultra low latency workflow at this time. And then marching down in the deliver phase, one of the things that we do to optimize, if you will, I mean, this is kind of spans more than just the deliver phase, but is that we keep everything within a single network provider. We keep everything within Azure so that we minimize back and forth between any different network providers or cloud providers. That introduces latency. Moving bytes from place A to place B slows things down. And then the last component is the player. That can typically be one of the largest introductions of latency in the workflow because, again, it's that buffering. If you have a 10-second buffer of your stream, the player is going to have a latency minimum of 10 steps, plus the encoding and unpackaging and all those things to get those stream really viewable to you. So we have done a lot to shave off time in the encoding, packaging, and playing phase of these. And I'm going to tell you just a little bit more about how we did that. Real quick, though. And one thing you'll notice about me is I like to say something once, I like to say it again, and I like to say it a third time because that's usually how things stick in our brains. A good educational practice. As with all things, right, there are optimizations, and optimizations typically mean there are trade-offs. It's pretty hard to have fast, cheap, and good all at the same time, and ultra-low latency streaming is not immune to this symptom. So we can do a lot of optimization, again, to reach the fastest, to reach your audience in the fastest possible way. But it does take out just a few of those safeguards that tend to go in place with longer latency streams to adjust for those network deficiencies or network variability, player variability, large wide-scale distribution of folks around your viewer base. Okay, so back to the story at hand. The way the stream comes into the player, right, has significant impacts on the stream latency. The ideal scenario is the delivery of many super small chunks to the viewer, which really minimizes that buffering impact. So it's just like this constant, tiny, constant small stream, but very, very steady and really, I don't know a better way to analogize it, but very laser focused from source to viewer. The problem that can introduce with some current streaming configurations is that you can get an explosion in the number of HTTP requests, or just what's called stream requests from the player. So to get around this, to have that laser focused stream and to try to avoid the backward traffic of tons and tons of requests, we do use here Wowza WebSockets and Wowza protocol. What that allows us to do is essentially have a push to player mechanism where you don't have to have this constant stream of requests. We're pushing out this laser stream of video from your source, out to all these users. So it is important to note that this WebSockets and Wowza protocol are something very important to our workflow for that optimal delivery. Okay, as noted, keeping everything within a single cloud provider, single provider of Microsoft Azure really helps minimize those latencies. We like to stay within that single cloud source to eliminate speed costs by going in and out of different networks. And Azure also has dedicated network links between the origin, the midgrass, and edge network, minimizing, again, those costs that you can incur from transport. Okay, so to cover off just what maybe a standard workflow looks like with an ultra low latency workflow, right? The process or the flow is generally the same, but there are some specifics that are different between, let's say, A and B. So we still take the signal from the camera encoder, as mentioned, but we bypass that transcoding, and we keep the output stream with the same resolution as the input stream, same resolution, frame rate, etc. To reach the players and the mobile viewers, your web viewers in under 3 seconds, we force all signal to go through the Wowza CDN in Azure, and we force Wowza protocol. We use WebSockets as kind of a handshake between viewer and CDN. This is going to reach all of your web and mobile viewers that are capable of these protocols in under 3 seconds. And it's going to be very reliable, and it's very scalable. One thing that we really do like to point out is that we provide fallback options. We want this to be accessible and available to all users. So we have something we just call this HLS fallback option. That repackaging in transmuxing is also a term used into that different protocol, does introduce latencies, so it's not necessarily going to keep your HLS streams at ultra low latency, but it's still going to ensure that you reach these other audiences. Okay, a quick note on GoCoder, in case you're not familiar, and I have mentioned this a few times so far. GoCoder is a free, fully functional mobile app developed by Wowza. It's available for Apple and Android. And it is really our mobile interface for both capturing and encoding as well as playback of live streams at any scale. To expand on that, we also provide this as a fully extensible SDK. So this is something that you could take as a streaming service and essentially use it to build your app around. So you can have your own branding, you can have your own other functionality working with it, but we provide all the ability for you to create your own mobile app, and you don't have to deal about any of the streaming components. You can focus on the other elements of your application that are important to you on top of the live streams. This is all for free. The SDK is for free, the GoCoder's for free, and it is available, as mentioned, on the stores, and the SDK is available on our website. Okay, so to recap real quick, and probably just a little bit further level of detail. Our ultra low latency workflows work with any H.264 RTMP enabled encoder. This means also you can fully use this with Wowza GoCoder. This is really great for user generated content if you wanted to do something like that in a social media type of aspect. We keep all network componentry within Azure until final delivery. We do bypass transcoding. We deliver at a single bit rate determined by the source. We employ WebSockets and Wowza protocol, really allowing for that smart CDN to player relationship that I talked about before. To achieve the sub 3-second latency for mobile viewing, the GoCoder app really needs to be used. This is kind of important. Or you need a viewer that supports GoCoder. I'm sorry, that supports the Wowza protocol. And we support, talking ahead of myself here. We support GUI workflows and a RESTful API. Sorry, that is language agnostic. So, introducing, hate it when I do that, introducing GUI-based workflows. So this is something that's new with Wowza Ultra Low Latency live streams. We rolled this out initially as an API based product, thinking that most of our users would really want to incorporate this into a larger application that they're doing. However, we heard you, and we found a lot of users would really just like to be able to create live streams with through a GUI interface, through the Wowza Streaming Cloud interface to produce their live events. So we listened, we heard you, it's in there. You can now click a few buttons and basically have an ultra low latency live stream up and ready to go in just mere moments. That being said, we have not backed off from the API. We do know very much that the API is very important to a lot of our builders, and it is still fully available and fully supported. We're just augmenting this. Both GUI and API tools are totally included in the Wowza Streaming Cloud Ultra Low Latency plan. No extra cost for either of them. They're fully included in that plan. Okay. So with the GUI enhancements, with the plug-and-play web viewer, with the GoCoder mobile app, Wowza has really tried to make low latency sub 3-second streaming as easy as possible for live event producers of all backgrounds, for our app builders, for our broadcast live event producers, so on and so forth. We wanted this to be something as seamless as possible. You don't really have to do any pre-config. You don't really have to do any advanced setup. You get in there in the GUI of the API, you basically go turn on a stream, you send a stream to it, you get your playback URL, and you go. It is designed to be that easy. It's designed to be in a fully managed infrastructure where you really do not have to take care of this infrastructure yourself, a plug-and-play solution, an extensible solution. It's impossible to always have a one-size-fits-all approach for everybody, but we're doing as best we can. Okay, so why at the end of this are we doing these low latency video streams, right? We wanted this to have to provide a lightning fast sub 3-second service. We want it to be rock solid reliable. We want it to scale to meet the needs of your audience, whether you're 50 people or 50,000, all on this fully managed infrastructure, so you don't really have to think about anything. We want this to be as easy as possible. To note, right, ultra low latency, regardless of what technology stack you're using, will have some trade-offs. It's just anything that comes with optimization, comes with some trade-offs. You're not going to have something quite as configurable as lower latency streams. You're going to have to use smart viewers. You're not necessarily going to be able to have transcoding or adaptive bit rates, but these are optimizations that we made to have this be the most performant stream we can possibly provide. Okay, on basically a final note, about to wrap up here and hand it over to our QA session. We do know that it's important for people to have some metrics on their streams. So we do provide some analytics so that you can see your average, your max, and your min connections. It can help you understand your audience size, your audience engagement. You can see who's dropped or who's new, either for the whole broadcast or for at any given time point. Right, think if you're doing a live broadcast and 20 minutes in, you see a huge drop off of half of your audience. And that was also the exact same time where maybe you did a major context shift in your presentation or a content shift. That's going to tell you real quick that maybe that was not a popular change or did not resonate with your audience. So that's the kind of information that we want to help people get out of their live streaming broadcasts to really improve and iterate as they go forward. Okay, thank you. I got this slide and then one last slide that I'm just going to leave up for everybody. As Justin noted, this is part of a webinar series. So we are going to talk in the next couple of webinars on technologies including SRT, WebRTC, CMath, and really how you can leverage these in the Wowza product family. If you go to this URL, you can sign up or see info on the rest of these webinars.
Although technically speaking, if you're here, you're already signed up for the other two webinars, which are specifically WebRTC, which is in December, and SRT and CMath, which is in January. Correct?
Excellent. Thank you for pointing that out. Yep. And that is really where I want to wrap up. And we're going to start the Q&A session. But something that I really want to point out because, again, by popular demand, we have included ultra low latency as well as API access into the Wowza Streaming Cloud free trial. This is brand new. We've not offered this before. It was not available for people to test drive. It is now fully available for anybody to test drive. ULL streams as well as API access. So please go out there, give it a test drive. We're really excited about this. We're extremely proud and confident of the scalability and reliability of this service. So have at it.
Before I get into questions over here for our experts, Jamie and Mac, who are both listening in right now, I do want to verify one thing. I think I love the fact that we are allowing ultra low latency on the free trials right now. But what about people who currently have just a Wowza Streaming Cloud account? Because I think we have about, I'd say, at least from the poll, 20% of the customers who already have them.
And we very much anticipated this question, right? So you will not be able to trial this within your existing account at this time. We definitely recognize kind of the need and demand for this. If you do want to go try this this functionality out, you'll have to essentially go set up a test account to go take this as a test drive. But it is certainly something that we're looking at bridging that gap going forward.
That was obviously a question that came in.
Absolutely. Absolutely.
But I just wanted to bring that off right at the bat. Another question, obviously, is people want to know, well, what about Engine? And well, I'm sure I think we're working on ideas specifically for Engine. Just so people who have seen it in the chat, I did send you a link on how to go from Engine directly into Cloud. So that is definitely something you can do. And check out the video to see it. So that being said, let's go into some questions. And we do have a couple of questions coming in here. The first question, I'm going to go from the top down. Somebody wants to know, is there a way to use ultra low latency, but only for audio?
Yes. Hi, this is Jamie. The ultra latency offering in Wowza Streaming Cloud supports video and audio, so you can readily use it for audio only now. Pete touched on this as far as some of the technical details for this offering. The codecs, to get real technical, the codecs are for video H.264 and for audio AAC. So anything you do will end up being an AAC based codec based stream. So you need to keep that in mind. But you can run again an audio only stream using the Wowza protocol. You can also then run, obviously with HLS, you can run an AAC audio only stream as well.
Great, awesome. And for people who are asking questions, please type them into the Q&A window, not the chat window. It's hard to go back and forth, and I'm not sure there's a bit of chat, so I'm not sure if I'm going to miss anything if you're typing it into the chat window. Now, Michael was asking a little bit about, he wanted to know if there was any relationship with our option with Akamai. So now you've already said it's the Azure network, right? It's not Akamai.
Yes. So who is this? Mark? Oh, it's okay. Got it. Hello. Yeah, so this does not use, so the current cloud offering we have today, I've had for a while, that uses the transcoder workflow, I like to call it, does use Akamai's CDN today. This does not. Essentially what we've built is our own CDN for ultra low latency on top of the Azure network. So not
Awesome.
Akamai.
And I think we've already mentioned it works with WebSockets.
Yeah.
That's time. We're also getting a question, is the Wowza protocol actually the messaging fragmented MP4 data through WebSockets to the DOM media source object?
So that's mostly right. The Wowza protocol is not a fragmented MP4 based protocol. It's not an HTTP based protocol. So it is a proprietary protocol that we created and optimized for this offering. Its history comes from its use in Wowza Streaming Engine when you use it in a distributed fashion with that software product. So it's a proprietary protocol, as I mentioned, and it is then essentially wrapped in WebSocket and delivered through the HTML5 or MSC-based player on the browser, and then through the GoCoder SDK for playback on using mobile apps. Awesome.
And Jang, I hope that answers your question on what does Wowza use as it is a protocol. Erwin asks, why are you using Zoom when Wowza has such these ULL capabilities? Erwin, tracking. That's pretty much it. Tracking, man. We gotta use something in order to know who shows up, right? All right, I hope that helps. We're also being asked, does our player support also Flash? So I guess you're asking whether we go through the player via RTMP?
So our current player, Wowza player offering it's kind of split today. We have a traditional Wowza player offering that supports HLS adaptive bitrate with a Flash fallback approach. And but again, that isn't RTMP. That is using Flash as a plugin. And then we have the ultra low latency Wowza player version, which supports the Wowza protocol and the HLS as a fallback. That is a for better or worse, a split offering today that will merge over time. So we just, when you use ultra latency, you still can use Wowza player. You've got to use a different version of it. That's all.
Awesome. Mark wants to know a little more about this unlimited scale. Can you share data on the largest audience concurrency data and the bitrate used to reach that audience?
Yeah, unlimited isn't unlimited. That's not true with, that's the case with everyone, right? With every CDN. So the current, since the ultra low latency feature's been released back in the late summer, the audience sizes that we're seeing folks use is in the tens of thousands. So for example, we have a particular daily event that runs every day and is currently at about a 30,000 audience size. And they are hoping to get to 100,000 and bigger down the road, and they certainly will be able to do that with us. But currently, what we're seeing is in the tens of thousands.
Great. I think Mark also wants to just verify using ULL in a web browser, and specifically, I assume we're talking about player here.
Yeah. Again, the ultra latency feature, given that it's a proprietary protocol, Wowza does not have a plugin to a browser. We are not plugin fans, at least I'm not. Anyway, so we use WebSocket to get into the browser. And so yes, browsers are supported, all the market-leading browsers that support MSE. That's the term you really need to keep in touch with, which correlates to HTML5, but media source extension is the official term for that acronym. Any browser that supports that will support this offering through Wowza Player. The way to really summarize it is kind of anything but IE support is supported. Hate to say that, but IE never fully supported MSE even in its latest incarnation. So Edge browser works though. Opera, Firefox, Safari, Chrome, all the big guys otherwise are good to go.
But that's still using Wowza Player.
Yep, and it's still using Wowza Player in the browser and our implementation. Yep.
Awesome. Bill has a little bit more detailed question here. He wants to know what percentage of a business audience can be reached with that Wowza protocol, because he wants to know how many people do end up failing over to HLS with the player.
Sure. So the Wowza protocol, in full transparency, works just about everywhere. It's not everywhere. The challenge we have today with the implementation in the browsers that I just mentioned is it does not work on iOS. So iOS browsers do not implement MSE, back to that MSE term. And so we cannot get into those browsers with the Wowza protocol. That's where there's really two other options, which again may not be ideal for everyone. One option is to use the HLS fallback stream, which again is at a reduced latency, not the same low latency. Or you can build a mobile app using the GoCoder SDK and then get on those iOS devices with ultra low latency. So not ideal, like I said. We keep looking at keep looking at ways to mitigate and remove that barrier, including talking to Apple, but no indications so far that they plan to do MSE anytime soon. So we will continue to look at other ways within our control means to support that gap today.
And Jermaine, I hope that also answers your question about why we are using HLS as a fallback protocol.
Yeah, one of the main reasons is really to get in those iOS browsers. You could argue that other reasons are there too. If the UL, it's treated as a fallback, and the UL stream, if it does fail for any reason, it would jump over to the HLS in the Wowza Player and GoCoder. So you have kind of a redundancy scenario as well.
Awesome. Thank you. Just to answer a few questions myself, not that I'm the expert here, but just saying, Mark, again, I know you said you had to use, sorry, things keep jumping around here. Again, you can't use ultra low latency at this time. You would need to test it in a trial, and if you were interested, I think you'd have to be switched over to a new account. Brian, yeah, it's not available for Engine yet. Again, I sent a link in the chat that would show you how to take a stream from Engine to Cloud. If you're interested in using that, definitely check that out. Patricia, same goes. Again, many people are definitely interested in using Engine to go ultra low latency. And at this time, this would require you to have a ULL account for Wowza Streaming Cloud. So I know I'm repeating it over and over, but people are asking it. I just want to make sure you're all aware. Okay. Okay, Bill is asking now, for enterprise events, where does Wowza's ultra low latency become a better use case versus tools like Zoom and GoToWebinar? And before they answer that, just to mention, there are actually other webinar tools out there which are using us to stream the video. But I'll take that over to Jamie.
Yeah, it should be made or re-emphasized that the ultra latency feature in cloud today is more of a broadcast one-to-many technology and not a two-way technology. While it has low latency and interactive two-way tools like Zoom and GoToWebinar and others are two-way tools, and that's where latency matters. This is more of a broadcast case. With that said, people are using it for interactive scenarios, but it doesn't necessarily fit into the two-way conversation style stuff. So it's not a replacement for Zoom, is what I would equate it to.
Agreed. Hey, Mac, Mac, I see some of these, you said you were going to answer these questions live, so I feel like I'm stepping on you here because I'm not asking you to answer anything.
You're good. No, you're good. No, I was just going to point out a couple of these. Mark Becker's, you had asked about. I've already subscribed. I'm in an active subscription with Wowza Cloud. How do I add ULL to that? And I would just suggest to all of you who if you're outside of the trial area, if you want to add it to your existing active account, just email billing@wowza.com. Let them know you're interested in that, and they can work with your account to add that option on. Okay. So that way you can still work with that, and if it's something, it's a simple change that we can make on our side. That way you get in, you can taste this. Alternatively, and I want to put this out there for Pete, and with our new trial experience, you can do a trial, but I would suggest adding it for now. It's a wash, only because we now in our trials can move all of your trial experience. We convert that to live production. So that's a new great feature that we've added in that area. So I don't want to see you open up two accounts, if that makes sense. Right, Jamie? We're good on that?
Yes. I think the thing I would add is when you're talking about adding it, we're talking about adding it as a paid item.
Correct.
And there's what we call a starter option that you can add. If that becomes a burden to you actually wanting to try the ultra low latency feature as an active paying cloud customer, though, that's definitely where you still want to reach out to billing. They will reach out to sales and even me in product to work with you to try to get it added to your account without that incurred cost. That's again something, as Pete mentioned, we're trying to get more get that barrier reduced so that you can just get into the ultra low latency trial as a paid cloud customer. But short of that, we can work with you if the starter option is not for you. So
Thanks.
Awesome.
Yeah.
Thanks, Mac. Okay, so I'm not sure from Jermaine if this is a question specifically for Engine, because he's asking about, will Wowza have CMAF stream targets for Akamai?
What I'm going to say is we're going to just be talking a little bit more about CMAF in one of our upcoming webinars. It's really kind of in progress right now, so I'm going to punt that question a little bit and say, come check back with us in early January.
Things are in progress.
Things are
just talk to us in January.
Work in progress.
All right. Mark's asking, does Wowza Go Coder and the CDN delivery currently support end-to-end chunked transfer? Well, once again, in CMAF. So again, I think the answer is talk to us.
Stay tuned.
Currently, the Go Coder support is the Wowza protocol. It doesn't rely on WebSocket. It's purely the Wowza protocol.
So right now we're all focused on the Wowza protocol, guys. But yeah, talk to us in January. Be sure to join our webinar once again, and you should get a reminder to come if you've already signed up. So if you signed up for this webinar, you will get the reminder on that webinar when it's about to start. I'm gonna pop past this one. I think some of these questions you guys definitely sent maybe while we were still talking about it, but just to reiterate some things, how to achieve a lower than 3-second latency with Wowza. Well, the answer is our ultra low latency service. So hope that answers that question. Mark just wants to make sure when he asks the question about audio with ultra low latency, he does mean stereo audio, not just audio. So
yeah, we don't do any stereo supported. We don't, with the ultra latency feature, we don't do any transcoding or any conversions there. So whatever comes in will go out, and stereo is fine. Yes.
Awesome. Graham wants to know, what tools can we use to track ultra low latency figures in real time?
The analytics are limited to what we have in our user interface for our API today. There is some real-time stuff you can look at as far as user counts and things like that. So I would go to the UI user interface, look at the analytics you see for these are essentially what we call a stream target in the user interface or in the API, and you can click on the usage there and check out what we have.
I think there's other companies externally, though, that also track this kind of data, right?
I mean, yeah, you could wire up any analytics application, but it depends what you're trying to inspect. If you're trying to look at something related to the protocol, that's custom.
Gotcha.
Right. If you're trying to look at just access to the link and anything relevant to where those people are, or where the requests come from and things like that, then yes, you can certainly do that today. So.
Graham, I hope that helps. Camille, she's asking again, how many users can we handle with Wowza live streaming? I think you were sort of explaining on a general level, like unlimited is not necessarily unlimited, but we've seen things up to like 30,000.
Yeah, I mean, bring your numbers to us. With that said, as I said before, unlimited is not unlimited, but we have built this to scale. It's not just to deliver the low latency numbers you expect, but it's to deliver those numbers at scale. And what we are seeing again with our current customer base is folks running simultaneously across the customer base events that are in the tens of thousands And those folks, again, hope to go into the 100,000, multi-100,000 range. And that, when we get to those points with those customers, those will not be problems.
Awesome. Jane, you're asking the question again, which is better, WebRTC or CMAF? Not sure if it's a question for today. Can we answer that?
I think that's a pretty philosophical question that is probably beyond the scope of today's webinar. And different scenarios get better optimizations out of different technologies.
Yeah.
There's no one size fits all.
Depends on what you're using it for. But you know what? You're welcome to talk to our sales department. They would love to discuss it with you. Is that sales at wowza.com?
Yeah.
Definitely check them out. All right, Phil. Does ultra low latency work with Wirecast as an encoder? Are there special settings for this? I'm going to tell you it does. It is RTMP.
Yeah, the ingest is the same as what we do with any cloud stream today. So it's RTSP and RTMP primarily. And Wirecast will work. As Justin said, there's no particular specific settings you need to set. It's the usual behaviors we would expect for any stream coming in. If you do have questions, we do have a support article out there for how to do this. So.
Absolutely. And can I just jump on that real quick, guys? Just from a support standpoint, one of the things that we just need to reiterate to you is currently now, since we're not transcoding or transmuxing this at all, really, whatever you send in is what you get out. So if you send in an extremely large bit rate for any reason, and your end users have limited bandwidth, they're going to choke. It's going to buffer. It's not going to be a good experience for them. So thinking across the board, your profile, your level that you're using on your encoders, those are effective. Usually, if you're only going to do a mobile audience, we would suggest using a baseline. If you're sort of across the board, use a main. Stay away from high if possible, and then also again watch your bit rate, just so that it's accessible to everyone. Keep it a cookie jar on the lower shelf so that no one has issues and has a good experience.
Thanks, Matt. Appreciate it. Hey, guys, we got about 8 minutes left on this webinar, so I'm going to just kind of dive through some of the basics out there. Some people are still asking about WebRTC. Can't really answer some of those questions, unfortunately, at this time. Please, we are doing some actual work even now with WebRTC. Check with us next month. December 13th is when we have the WebRTC webinar. In terms of people asking about when will ultra low latency be available for Engine, once again, this specifically we're talking about is cloud. You can stream to Engine, and I've sent the video on how to do that. I hope that helps. Let's try to, some people are also asking about using other tools like Ephesian. I can never pronounce that. Is that
Epiphan? Yeah.
Epiphan. There you go. Thank you, Matt. There's my inability to pronounce anything in English happening here. Pearl with RTMP. Yes. RTMP will work. RTMP for sure. I have been doing many tests these days. When I do videos, guys, if you ever check out YouTube and check out our Wowza videos, I do quite a bit with OBS. So I'm sending out via OBS RTMP. I use that simply because it's open source. Anybody can test and use it. But again, if you have an encoder that's using RTMP, definitely you can send it out to ultra low latency. Does your ULL Smart Player need any plugins? No. Jamie did talk about what browsers it works on and does not work on, but it's not plugin.
That's listed in our support article as well, the introductory on all ultra low latency. But yeah, you don't need a plugin in the browser. Not at all. Just need a browser that supports MSE.
Okay, so I'm going to jump to some of the more detailed questions, guys. I think we've kind of covered those repeatedly. Camille is looking for scaling possibilities. I mean, we talked about it in terms of what our reach is. So please, Camille, send some of your information if you have to sales, and we can talk about what exactly you're looking for there. Now, Jermaine says, we tested Wowza ULL streaming and we found that there are 3 significant limitations: time to start, autoplay, and video freezes if the browser tab is inactive for too long. I think you just wanted some comments about this.
Yeah, so these are all things we're very well aware of. Apologies. We are on the startup we're working on that in this development cycle this quarter to improve those situations. One effort is what we call time to first frame, where we will actually help reduce the time to start that stream in a general sense. Just know that it's tied to a situation which is normal in a CDN, where the first pull in a region of a series of content or live stream requires it to go back to origin. That takes a little longer. We are working on an additional project to ways to reduce that time as well. So that start time we're trying to bring in to a lot better situation, and expect some results in the first quarter next year to come out. The freezing we're aware of that too. That's something we would have to defer back to the player team on to see where they're at with that. I believe they're looking at it, but I also believe that certain browsers it's out of the control and really an MSC thing. So we could take note. If you want to send us an email or reach out to the folks here on the webinar, we could coordinate a conversation around that, or you could send something into support and we could route it that way. And then the autoplay is again a player thing. Wowza Player supports autoplay, or has historically, I should say. But it's currently disabled because of all the discrepancies across the browsers about what's allowed for autoplay and what's not. I personally just was at a developer conference where we talked with industry leaders, folks that work at Google, folks that work at Apple and Safari, and then Firefox, where there is, for better or worse, there's no standards around autoplay behavior, and there are standards being generated. I know Chrome has their continued releases where they reopening the door for autoplay. All I can say is we can look for you can look for situations where we will in the near term try to support what Chrome is doing as far as those changes in their autoplay behavior. Firefox could be on there too, but the challenge is we won't holistically solve it immediately, because again, we're waiting for the browsers to kind of settle on what they want to do.
Awesome, thank you. Guys, I see some other questions specifically about what the actual URL is to connect to ULL. I mean, definitely please check out the videos or try out a trial and see how it works. That's the best way to get that kind of information and see it working for yourself. There is a great question that's come up a couple times here, so I'm just gonna pass it over to Jamie, because I'm kind of curious myself. As we've repeatedly said, the ultra low latency is using the Wowza protocol. So the question comes into play, while we have the Wowza player, are there any other third-party players out there that accept the Wowza protocol, or will accept the Wowza?
It's a great question. Not today. It requires the combination of the protocol plus the WebSocket implementation we've done. We are in conversation with third-party player companies like JW and Bitmovin and others to support this. I really think it's kind of up in the air still as to when we land with third-party integration. It remains a top priority, but I think it also may end up lending itself to the future webinar, where we talk about technologies like CMAF, which have, because it's Dash and because there's also a low latency HLS initiative, those technologies will lend themselves to third-party integrations that just work. So we continue to look at this. Can probably update you in the next webinar as to whether we've made progress by then or not. Like I said, it remains a top priority, but lots to consider there. So.
All right, thanks. I'm going to leave this at 3 other questions here that are kind of curious to me as well as we're asking. One is more about specific RTMP, I suppose, settings that you might want to set up. For example, max bitrate for ULL, and if we're not doing ABR, should be using CBR.
You should be using CBR for sure. We have a great article in our support documentation that talks about encoding settings for cloud in general, and that would apply to ultra low latency too. I would encourage you to look at that. We could send it out to the group here or something of that nature. But there is an encoding guide, best practices guide for cloud as a whole, which would include, again, ultra low latency. Specific to your question, constant bit rates for all is a better choice. There's all kinds of information about ideal resolutions that match bit rates, that match keyframe intervals and the like. And I would just, it's a nice little table if you just want to not read and go down to the table. I would encourage, that's probably what I would do. So I would encourage you to check out that article and ask us questions after that.
And last question I have here, because this is the last question we even have time for. Actually, we don't have time for it, but I'm going to do it anyway because I'm kind of curious. We do have people in our sales department who love to stream with ultra low latency from their drone. So the question being is, can you do that with video only, no audio?
Yes, you can do video only. We actually have customers doing it. So with drones.
Absolutely.
So yes.
All right. Well, hey, Jamie, thank you for your time.
Thank you.
You as well, Mac. And Pete, I appreciate you doing the presentation. This webinar will be available for viewing later. We will send you an email regarding that. But if you do have other questions that have not been answered here, please send them to our support department. Mac, is that okay if they contact our support department on this?
Absolutely. Send us any questions you have. If it happens to be a pre-sales question about your workflow and how do I do this and what would be best, we'll forward that on to the sales team and they'd be happy to work with you as well.
Awesome. All right. Well, thank you everyone for attending this webinar and I hope you all have a great day. Take care.
Thanks, guys.
Thanks.